Okay, so number 24 on page 191 says a 1975 kilogram car is parked at the top of a steep 42-meter long hill. So this length is 42 meters. And it tells us that the angle is 15 degrees. That's right here. So the car is up here. We have FG acting down. So there's an FGY going this way and an FGX going this way, and an FN acting up. And it says it starts to roll down the hill. If it starts to roll, it means VI is 0. How fast will it be going at the bottom? You're looking for VF, and the 42 meters is going to be your delta D. So you need to find A, and you can find A with the sum of the forces. Now, we've been trained to do sum of the forces in the Y direction first. And if we did that, we would have Fn minus FGY equals 0. So that means Fn equals Fg cos theta, or Fn equals mg. So we've been trained to do that first, but the reality is we don't need it in this one because there's no friction. So we could have just gone to sum of the forces in the x direction. And the only one is Fgx. And it's equal to max. Fgx is the opposite side, so it's going to be mg sine theta is equal to max. The m's will cancel, so ax equals g, 9.81 meters per second squared, times the sine of 15. Punch this in your calculator, and you should get 2.539 meters per second squared. Once you get that, you can come back over here then and do VF squared is equal to VI squared plus 2A delta D. This goes to 0. VF squared equals 2 times 2.539 meters per second squared times 42 meters. And then don't forget to take the square root. And when you do, you should get 14.60, I think it's 604 or something like that. I'm just checking my work. Meters per second. Okay? Number 24. Number 25, starting from rest, a cyclist, so we're starting from rest. I have all kinds of space here, so VI is 0. Starting from rest, a cyclist coasts down a starting ramp at a professional biking track. If the ramp has minimum legal dimensions, 1.5 meters tall and 12 meters long, so this way will be 12 meters, right? And so we can find this angle, inverse sine, should be 7.181, I think, degrees. And it says, first, neglecting friction, find the acceleration of the cyclist. So here's the cyclist. Here's their FG, their FGY, their FGX, their FN. So in part A, we don't have to do sum of the forces in the Y direction because there's no friction. So we can go right to sum of the forces in the X direction equals max. And there's only one. It's just the FGX. So FGX equals max. So mg, and it's sine theta, equals max. The m's cancel, so ax equals 9.81 meters per second squared times the sine of 7.181. And if you don't round at all, you get an ax of 1.22625 meters per second squared. That's part A. Part B actually adds friction in, and since the cyclist is coasting down, friction would be going up. So now in B, we have to do sum of the forces in the Y is equal to MAY, but the cyclist isn't moving in the Y, not floating in the air or falling through the incline. So in the Y direction, we have Fn minus FGY equals 0. So Fn will equal mg cos theta. Okay? Even if you wanted to, you wouldn't be able to find this value. You now have to go to sum of the forces in the x. So this time in the x, there's the FGX going down the plane, and down's positive, minus friction, which is going up the plane, and down's positive because that's the way the cyclist is moving, is equal to max. FGX is really mg sine theta minus friction is really mu Fn is equal to max, but Fn is mg cos theta. So this will be mg sine theta minus mu mg cos theta is equal to max. There's an m in every term, so cancel it out. So ax is equal to g, 9.81 meters per second squared, sine theta, sinus 7.181, minus mu, which they told us was 0.11, times g, 9.81 meters per second squared, times the cos of 7.181. And you get an AX of 0.156, I think, meters per second squared. That's part B. Part C then says the time it takes to reach the bottom of the ramp if the friction is acting as it says in part. So if using this friction, it says it starts from rest, the ramp is 12 meters long, and it wants the time. So delta D is equal to VI delta T, 1/2 A delta T squared. Starts from rest, so this goes to 0. So T squared equals 2 delta D over A. So 2 times 12 meters divided by 0.156. And you can keep all those decimals in your calculator, of course. Don't forget to take the square root, and you should get 12.42, I think, seconds. All right? And the last one, number 26, says, a skier coasts down a 3.5 degree slope. It's a pretty huge slope. Scary. At a constant speed, so AX is 0. Find the coefficient of kinetic friction between the skis and the skier. So here's my skier. Here's FG. Here's FGY. Here's FGX. This is Fn. And if they're coasting down, then friction is going this way. So again, some of the forces in the y direction, the skier's not moving in the y. Remember, we've slanted our incline, so moving in the y would be floating up into the air or sinking into the incline. So Fn minus Fgy is equal to 0. So Fn will be equal to Fgy. So Fn will be equal to mg cos theta. We go to the x direction. Sum of the forces in the x direction is equal to max. In the x direction, there is Fgx going down the incline, friction going up the incline, and it says at constant speed, so this is equal to 0. So we have Fg cos theta is equal to, take the other one over, mu Fn. But this is my Fn, so mg cos theta is equal to mu mg sine theta. The mg's will cancel, and you're trying to solve for mu. So divide both sides by theta. So sine theta. So mu will equal, oh, did I just screw up? I did. This is cos theta. And this is sine theta. How did I do that? I even had cos theta over here, and then this is why it happens when you're not with me. So this should be mg sine theta, that's an m, g sine theta, is equal to mu mg cos theta. Sorry about that. Okay, because x is sine. And so the mg's cancel. Divide both sides by cos theta. And you get mu equals sine theta over cos theta, which from math you might know is equal to tan theta. So they told us the angle was 3.5 degrees, so take tan of 3.5 and get 0.06116. And you are done. Sorry about that mess up there. Just totally ignore that. I'm going to blame it on the hours. So FGX is sine theta. It's the opposite side. All right? Very good.